My name is Mitsuki Tatsuno. I'm gonna start a presentation of my study. Actuators are mounted to small productions like a smartphone or wearable device which fit into the palm of one's hand too. However, the size of mechanical actuators which are generally used is so large. Therefore, mounting mechanical one of these miniature devices is difficult and more minimizing actuators are required. Recently, as a new material for small actuator, shape memory alloy wire is attracting the attention to fit this requirement. Shape memory alloy has special properties which can be back in a basic form by heating. Additionally, recovery power has occurred when this material's form recovers, so it is possible to use it as an actuator. However, the stiffness of ASML wire is low because of that material's properties, so it is regarded as fabricating complex and flexible structures only using ASML wire without fixture is difficult. Also, the ASML method is employed to fabricate 3D lattice structure using shape memory alloy. Is regarded as ASML method takes a long time and the cost of this method is high. Therefore, we first propose developing a new filament composed ASML wire to high viscoelastic gel as an objective for improving the formability with viscosity. And we propose fabricating the unicell type 3D lattice structure employing the FDM method using this filament as a method to solve the problem about time and cost of forming. From the above problems and suggestions, this study's objective is to develop the unicell type 3D lattice structure using cracked core filament which ASML wire is core and gel surrounds the wire and clarifying the modern geometry. Affects the deformation behavior of 3D lattice structure ASML actuator which is fabricated by this filament. I will introduce the proposed unicell properties in this study. The unicell consists of one frame and 6 beams of support frame. This beam is capable of bearing the stiffness. Additionally, it is possible to fabricate a 3D lattice structure that has fearless behavior by changing the stiffness of this beam and connecting with other unicells. For example, by arranging several unicells in a row with stepped stiffness of the side beams as shown in the above figure. The structures can be predicted to have torsional behavior when loaded from above. Therefore, in the future, we will define the material model of filament which is composed of ASML wire and high viscoelastic gel for forming a 3D lattice structure and make the model of that one. Additionally, we will analyze the deformation behavior when the model is deformed too. We first made the unicell type analysis model of a 3D lattice structure which is capable of complex behavior. Second, we propose a new filament composite of ASML wire and high viscoelastic gel is needed to fabricate this structure without using any fixtures. In the future, we will make the material model of this filament and analyze the deformation behavior of the structure that are fabricated by the new filament. This is the end of my presentation. Thank you for listening.